To determine the maximum number of 300-watt incandescent lamps that can be installed on a 20-amp, 120-volt branch circuit, you need to understand the relationship between wattage, voltage, and amperage, as defined by Ohm's law and the National Electrical Code. The fundamental principle is that the total wattage consumed by all the lamps on the circuit must not exceed the circuit's maximum capacity. The formula we will use is derived from the basic power equation, which states that power in watts equals voltage in volts multiplied by current in amps. Mathematically, this is expressed as watts equals volts times amps. In this scenario, the circuit is rated for 20 amps at 120 volts. To find the total wattage the circuit can handle, we multiply the amperage by the voltage. Therefore, 20 amps multiplied by 120 volts equals 2400 watts. This means the circuit can safely supply up to 2400 watts of power. Next, we need to consider the wattage of each individual lamp. In this case, each incandescent lamp consumes 300 watts. To find the maximum number of lamps that can be installed on the circuit, we divide the total wattage capacity of the circuit by the wattage of each lamp. Therefore, 2400 watts divided by 300 watts per lamp equals 8 lamps. This calculation shows that a maximum of 8 300-watt incandescent lamps can be safely installed on a 20-amp, 120-volt branch circuit, assuming there are no other loads on the circuit. The formula used to calculate the maximum number of lamps is as follows: number of lamps equals circuit rating in amps multiplied by voltage in volts, divided by wattage per lamp. This formula is a direct application of Ohm's law and is consistent with the guidelines provided in the National Electrical Code, specifically Article 210, which covers branch circuit requirements. It is important to note several considerations that can affect this calculation. Firstly, this calculation assumes that the circuit is dedicated solely to these lamps. If there are any other loads connected to the same circuit, such as receptacles, appliances, or other lighting fixtures, their wattage must also be included in the total load calculation. For example, if there is a small appliance that consumes 200 watts connected to the same circuit, the available wattage for the lamps would be reduced to 2200 watts, 2400 watts minus 200 watts. In this case, the maximum number of 300-watt lamps would be reduced to 7. 2200 watts divided by 300 watts equals 7.33, which we round down to 7 lamps to ensure we do not exceed the circuit's capacity. Secondly, it is also crucial to consider the inrush current of incandescent lamps. Incandescent lamps have a high inrush current, which is the instantaneous current drawn when the lamp is first turned on. This inrush current can be significantly higher than the lamp's steady-state current and can potentially trip the circuit breaker if too many lamps are turned on simultaneously. While the calculation above provides a theoretical maximum based on steady-state wattage, it is a good practice to direct the number of lamps slightly to account for the inrush current, especially if the lamps are frequently switched on and off. Thirdly, the National Electrical Code provides guidelines for branch circuit loading. According to the NEC, branch circuits should not be loaded to more than 80% of their maximum capacity when supplying continuous loads. A continuous load is defined as a load that operates for 3 hours or more continuously. If the lamps are expected to operate continuously, the circuit should be derated to 80% of its capacity. In this case, 80% of 2400 watts is 1920 watts. Therefore, the maximum number of 300-watt lamps would be reduced to 6. 1920 watts divided by 300 watts equals 6.4, which we round down to 6 lamps. Fourthly, the type of overcurrent protection device, such as a circuit breaker, also plays a role. Circuit breakers are designed to protect the circuit from overloads and short circuits. However, they also have a trip curve, which defines the relationship between the current and the time it takes for the breaker to trip. The trip curve can vary depending on the type of breaker. Some breakers are more sensitive to overloads and may trip more quickly than others. It is important to select the appropriate type of breaker for the application to ensure that the circuit is properly protected without nuisance tripping. Fifthly, the voltage drop in the circuit should also be considered. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the wires. Excessive voltage drop can cause the lamps to dim and can also damage equipment. The NEC provides guidelines for voltage drop in branch circuits. According to the NEC, the voltage drop should not exceed 3% for lighting, heating, and power loads, or 5% for feeders plus branch circuits. To calculate the voltage drop, you need to know the length of the circuit, the size of the wires, and the current flowing through the wires. If the voltage drop is excessive, you may need to increase the size of the wires to reduce the resistance. Sixthly, the ambient temperature can also affect the ampacity of the wires. The ampacity of a wire is the maximum amount of current that it can safely carry. The ampacity of a wire decreases as the ambient temperature increases. The NEC provides ampacity correction factors for different ambient temperatures. If the ambient temperature is high, you may need to increase the size of the wires to compensate for the reduced ampacity. Seventhly, the type of wiring method used can also affect the ampacity of the wires. The NEC specifies different ampacity ratings for different wiring methods, such as conduit, cable, and open wiring. The wiring method affects the ability of the wires to dissipate heat. Some wiring methods, such as conduit, provide better heat dissipation than others. It is important to select the appropriate wiring method for the application to ensure that the wires can safely carry the required current. Eighthly, the condition of the wiring and connection should also be checked. Loose connections, corroded terminals, and damaged insulation can all increase the resistance of the circuit and can lead to overheating and potential fire hazards. It is important to regularly inspect the wiring and connections to ensure that they are in good condition. Ninthly, the use of energy-efficient lamps, such as LED lamps, can significantly reduce the wattage consumption and allow for more lamps to be installed in the same circuit. LED lamps consume significantly less power than incandescent lamps for the same light output. For example, a 10-watt LED lamp can provide the same light output as a 60-watt incandescent lamp. By replacing incandescent lamps with LED lamps, you can reduce the total wattage consumption and increase the number of lamps that can be installed on the circuit. Finally, it is always recommended to consult with a qualified electrician to ensure that the electrical installation is safe and compliant with all applicable codes and regulations. A qualified electrician can perform a thorough inspection of the electrical system and can provide recommendations for improvements and upgrades. In summary, to determine the maximum number of 300-watt incandescent lamps on a 20-amp, 120-volt branch circuit, you can use the formula number of lamps equals circuit rating in amps multiplied by voltage in volts, divided by wattage per lamp. In this case, the maximum number of lamps is 8, assuming there are no other loads on the circuit and that the lamps are not operated continuously. However, it is important to consider other factors such as immersed current, branch circuit loading, overcurrent protection, voltage drop, ambient temperature, wiring method, and condition of the wiring to ensure that the electrical installation is safe and compliant with all applicable codes and regulations.